All right, today we start chapter 4, properties of matter. Remember, matter is everything that you study in chemistry. It's everything you can touch, see, or feel. And here they show an example of wood going through some chemical change, some serious changes, because when you're done, it's not going to be wood anymore. Okay, so every substance has a set of properties that are unique to that substance. They give it its identity. And there's actually two types. There's physical and there's chemical. Okay, if you're talking about a physical property, you're talking about the composition, you're describing it. You're going to say it's brown, it's a liquid, it is in its boiling point is, its melting point, it dissolves when you put it in water, things like that. All I'm doing is describing it, and I'm not altering its composition, okay? So whenever you're describing what something looks like, then you're talking about its physical properties. Okay, again, here's some examples. Its color, its taste, even though we don't use taste too much in chemistry, guys, not a good idea. Odor, its state of matter, by that, is it a solid, liquid, or gas? Its density, how close are the particles, its melting point, its boiling point. Again, all of these are describing what it looks like, and those are physical properties, okay? Chemical properties, you're talking about how it changes into something new, okay? You're going to say it, one of the key words is reacts with. If you see the word reacts with, you know it's a chemical property. Reacts with air, reacts with acid, reacts with water, that kind of stuff. But you're going to describe how it changes into something else, okay? So if we're talking about chlorine gas, okay, we can say it's a gas. It's kind of a greenish color. It has a bad odor. You can even say it's a good disinfectant, okay? It's 4 times heavier than air. Those are all describing what it looks like, okay? And we can say, when you take chlorine and react it with sodium metal, you produce salt, okay? So now you're talking about how it changes into something else. So physical properties describe what something looks like. Chemical properties describe how it changes into something else, okay? The properties of substances, again, here we have, the physical ones. If you're talking about chlorine, the color, its odor, it's a gas, melting boiling point. Here we have oxygen, colorless, odorless, it's a gas. And again, these are all physical properties. The thing to remember about substances, no two substances are going to have the same physical and chemical properties. They're not identical. They could be close, but they would never be identical. They'd be different substances, okay? Now, when you change things, okay, you can change things physically or chemically. A physical change is you're going to change some physical property about that substance, but it's still going to be the same substance. For instance, if I take ice, which is water, and I melt it, it goes from a solid to a liquid, but it's still ice. Sorry, my dog. Anyway, anytime you have the same substance, but it's in a different form, like you take a piece of paper and you tear it in half, or any of that kind of stuff where you still end up with the same substance, you know it's a physical change, okay? So here they have them showing them sawing wood, okay? When you're done, you'll have 2 smaller pieces of wood, and that's a big log, but it's still wood, okay? So you didn't change it, it's still wood, you're just changing its shape, okay? In a chemical change, you're going to get new substances, and the new substances are going to be different than the ones they're formed from. Okay? So new substances, they're going to have different properties, and their composition is going to be different than the original material. Okay? Here's an example of when you take copper. Copper metal, when you heat it in air, it actually reacts with the air and produces like a corrosion on the copper. It turns black, and it's called copper oxide, okay? So you started with this substance, pure copper. You heated it, which caused it to react with the air, and now you have copper oxide, which is not the same as copper, okay? And again, common physical and chemical, here's some examples. Rusting. Some people think rusting, well, it's still, no. Rusting is a chemical property because rust is iron oxide. Iron oxide isn't the same as iron, okay? Boiling of water, it's physical because you're just changing it from a liquid to a gas. Some people think, well, it disappears. Not really. It's air, it's vapor in the air. You can't see it so well, but it's still there. It's still just water. Burning. Anytime you see burning, you guys, it doesn't matter what you're talking about. If you're burning something, it's chemical. Boiling an egg, it's going to be different when you're done. So baking, boiling, cooking, or boiling of an egg, sorry. Anytime you cook, bake, anything like that, it's going to be chemical. Combustion is a chemical word. So combustion of gasoline means you're burning it. Okay, digestion of food, obviously you're adding chemicals to it. You're going to have a chemical reaction. It's the only way we break down our food. Now, if you're talking about like when you chew your food, if you don't add the enzymes, that would be chemical because you're just taking an apple and breaking it down into smaller pieces. But once you start adding enzymes to it, now you're chemically digesting it. Okay, here we have sawing of wood, physical, burning of wood, and again, burning. Anytime you say burning, okay, glass, if you heat glass, what it's going to do is instead of being a solid, it's going to be a liquid. It's going to change its shape, but it's still glass, okay? So again, if you have the start and end with the same substance, it's a physical. If you end up with a new substance with new properties, that's chemical, okay? All right, which of the following is a physical change? We're grinding a rock into powder. We have hydrogen, oxygen reacting to form water. We have a shovel rusting. We have an acid and base reacting, and we're burning sugar. Well, here we have burning. We have reacting and reacting. Rusting, we said, was a chemical reaction, so it has to be A. Okay, go away. Which of the following is a chemical change? Okay, melting. Oh, sorry, you guys. Now I gave you the answer. Anyway, if you melt aspirin, it's still aspirin. If you break a plate, it's still a plate. If you boil antifreeze, it's still antifreeze. Okay, if you put sugar in tea, yes, the sugar looks like it disappears, but it just dissolves. If you get rid of the liquid, the sugar's back. But lighting a match, you're burning something, chemical, okay? All right, when you're talking about chemical equations, or when you're talking about chemical reactions, you can represent it with a chemical equation. A chemical equation is used to represent a chemical change, okay? Here they have water decomposes into its elements when electrolyzed. In other words, you add a little jolt of electricity to it, okay? So we're going to represent it. We have water. Water is H2O. And at room temperature is a liquid. And when we add electricity to it, it breaks down into hydrogen gas and oxygen gas. You guys may have seen this. They have like little tubes, and they collect oxygen and hydrogen gas in each tube. Okay? So if you look at this equation, there's some things you need to know. For instance, this, whatever you start with, whatever's on the left-hand side of your equation is called your reactants. It's what you start with. Okay? In this case, we just start with one thing. Sometimes we start with many. So think of if this is a recipe, your beginning ingredients, okay, whatever you start with are called reactants, okay? Then what you make, what you end up with is called your products, all right? So this is my reactant and these are my two products. You can have 7 reactants and 4 products. You can have, it doesn't matter the numbers, but this represents a chemical change or a chemical reaction. The arrow, if I was reading this, I would say water yields hydrogen gas and oxygen gas. Okay, so the arrow means yields. It means produces. It's what breaks it into the two parts. Here's the reactant and here's the product. Okay, a physical change usually accompanies a chemical change, but not necessarily. But it's common. Okay, all right. Whenever you're talking about a change, you're going to, like especially a chemical change, you're going to have a change in energy. Okay, energy is the capacity or the ability to do work. And whenever you have a chemical change, you're going to have a change in energy. All right, I should say change in form. The amount of energy you start with and the amount of energy you end with is always the same because we can't change. The amount of energy we have always remains the same. You can't destroy energy, you can't create it. And you're like, yeah, I can, burn stuff or whatever. Yes, but what you do is once you burn a log of wood, now you've changed that energy in the wood, which is called potential energy, into heat. And the heat escapes into the atmosphere and you're thinking, well, I got to throw another log on there. Well, yeah, you do, but if you could keep it in a contained system, that heat would always be the same. It would, but it doesn't. It escapes. So even though it sounds kind of fishy, all we do with energy is change its form from one to another. Okay. We have mechanical energy, like if you put gas in your car, you burn it, and then it changes the heat that you get from burning the gas into mechanical energy, which makes your car move. There's chemical energy. Food has a lot of chemical energy. It's, an apple sitting there, you eat it, then your body changes it into energy for you. Electrical, nuclear, those are all examples of energy, okay? Now, if the energy is just sitting there and not being used, like I said, the apple, until you eat the apple, you're not using the energy, okay? So there's potential energy. If you have a lump of coal, you have energy in that coal, and until you burn it, you're not getting anything out of it. So it has potential energy until you use it, and potential energy is called energy of position. Okay, here they're talking about, yeah, you have a ball located 20 feet above the ground. It has much more potential energy than if it was 10 feet above the ground. Okay, so you can work with your potential energy as well. Okay, if you're talking about food, the food is there. If you have your apple, it doesn't matter if you move your apple around, it still has the same amount of potential energy. Okay. Okay, kinetic energy is energy of motion. It's the energy you possess due to motion. And as you heat things up, like when you have a solid, it doesn't have a lot of kinetic energy, it has a lot of potential energy. And then you heat it up, and then it starts moving a little bit. Shh. Then it has more kinetic energy, and then less potential energy. And when you get it to a gas, then it's really cruising. Okay. Another example, if you remember the bike, as you're going down a hill, you have lots and lots and lots of kinetic energy. As you're going back up the hill, you get less and less kinetic energy and more potential energy. And you reach your peak of potential energy when you're at the top of the hill. And then you start going back down again, and then you increase your kinetic energy. So you can go back and forth between the two. Here's an example. The water, as it's coming up to the dam, has a lot of potential energy. Once it goes over, then it has a lot of kinetic energy. And we use this kinetic energy right here to turn turbines and get electricity, hydroelectric power. Okay, so it's easy. Energy is really very easy to convert from one form to another. Okay, in a chemical reaction, the most common way that we change energy is heat. Okay, we burn things or whatever. So that's the most common way to do it. There's other ways of doing it, but heat is usually our change in energy. Okay. You know what? We're 12 minutes in, and this is kind of all new stuff. So we'll talk about this later. Okay. So we're going to end today, but remember we have two types of changes. We have physical changes and chemical changes. And we also have physical properties and chemical properties. Physical properties describe, chemical properties explain how you change into something else. Physical change, same substance, different form. Chemical change, different substance. You start with one thing and you end up with different things. And then we talked about the different types of energy, kinetic and potential. Okay, so that's it for now. Make sure you do your assignment afterwards, and we'll talk to you soon in the next part of the lecture.